Hello and welcome to another episode of NASA Science Live, an opportunity for you to interact with NASA scientists and have your questions answered in real time. I'm your host, Joy Eung, and tonight we are live at NASA's Goddard Space Flight Center as the total lunar eclipse is nearing totality. So it's a little bit overcast here right now, but luckily we're going to be taking you to different locations with clear skies throughout the show. So if you have any questions at all about the total lunar eclipse or why NASA is heading back to the moon, send your questions in using the hashtag AskNASA or wherever you're watching this show today. And as you can see, we will have a constant live feed of the lunar eclipse. So thank you so much to our friends at Time and Date for providing that feed. So as you can see, there's a lot of excitement in the air, and we have a lot in store for you as we track the lunar eclipse from North and South America and parts of Europe as well. We have NASA scientists answering your questions, and we also have feeds of telescopes dotted all around the world that are fixated on tonight's celestial event. And there's a chance that you too can see the lunar eclipse as well. So if you do, snap a photo and share it with us on social media or wherever you're watching tonight's episode. There's a lot to talk about, and we have a lot of questions coming in online. But first, let's go over to my co-host, James Traley, who can tell us where we are in the eclipse right now and what's in store for us in tonight's total lunar eclipse. Hey, James, how's it going over there?
Good. There are some extreme microclimates out there, but unfortunately just a couple feet away from you on the other side of the building. It's also overcast and rainy. So not holding out, for a good view from here at least, but we're tracking it all across the world. The view behind me right here is from Cartersville, Georgia, where there's a little bit of cloud cover, but we've got a really nice view coming into focus. Tracking this from around the world as well. We got some feeds from Morocco, all over Spain, and it's just going to be a phenomenal show to view from there. So is this your first ever eclipse?
Well, the last lunar eclipse I saw was in 2019 in Mexico City, actually, and it was an amazing experience. What about yourself?
It's been, I think, at least a decade for me. It's been a really long time, and I guess I'm going to have to keep waiting as well, but live vicariously through the amazing feeds that we've got out here as well.
So how many feeds do we have tonight?
Yeah, quite a few. I think I'm tracking at least 8 here so far. There's some that are kind of cycling through for me as well, too, from parts of the west coast of the United States. Out in LA, we got a really cool view from Ontario, Canada as well. A lot of places are fighting with a little bit of cloud cover, so we'll kind of see how that develops over the night as well. One of the views I'm tracking as well is from Rome, Italy, where as the night goes on, the moon is going to get lower and lower in the horizon. We might even get a view of the Colosseum as well, which would be fantastic as well. But at least for right now, let's learn a little bit more about the science behind a lunar eclipse.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
So right now I'm joined by science visualizer and our telescope guru for tonight's events, Ernie Wright.
Hi, James.
Ernie, thanks so much for joining us.
It's a pleasure to be here.
It's a little bit of a cloudy night, but we're still, tracking this from across the world here. Right now, we can actually see a shadow starting to creep a little bit across the moon. Can you tell us where we are right now in the process?
Right. I mean, we're a little bit more than 50% covered in the partial phase, and this is where the umbra is starting to track across the moon. In this view, it's a little bit dark, a little bit farther out because of the exposure that they're using, but over the next half hour or so, we should expect this darkness to completely spread across the moon. And then when they change the exposure, because the moon's so dim during totality, hopefully we'll see some red color there too.
Very excited about that. And if you're keeping score from home and you want to sync up your events so you're outside at the right moment, there's a good chance that you can capture this from your own backyard. So we want you out there sharing your pics with us as well. We've got the schedule up here. Could you just kind of walk us through some of the highlights?
Right. So before we came on even, the partial began, and that's the point where the umbra is starting to cover the moon. About halfway through our program at 11:29, totality will begin, and that's when the moon, all the brightness will stop dazzling your eyes, and you can see sort of that dark red color at 11:29. Maximum eclipse, this is when the moon is in the middle of the shadow, in the deepest part of the shadow. That occurs about 10 minutes after we're done here at 12:11 Eastern. And the eclipse continues for another 45 minutes or so.
Yeah, so it's a longer one, 85 minutes or so. This is not usually the case. Usually they're pretty short. So you got some time to grab a coffee, get your camera set up. Why is this one different, I guess, from the rest in terms of length?
It has a lot to do with whether or not it's going through the middle of the shadow or kind of skimming along the edge. This eclipse is in the top 25% of eclipses for duration, so we're pretty close to the middle. It gives everybody lots of chances to go outside. If it's cloudy where you are right now, wait a couple of minutes and try again.
Yeah, we're just tracking this now. The conditions are changing so quickly. The cloud cover is kind of moving over. And as I mentioned, we really do want you to capture this moment for us as well from your own backyard. What are some tips for people to get that best shot, with whatever camera they're using, even their cell phone?
Right. I mean, for one thing, it should be pointed out that we don't need any special equipment to see it. You can go outside with your naked eye. And you can also see it with binoculars. But if you want to take a photograph, you'll need longer exposure. And you'll want to probably set your camera not to night mode, because if you set it to night mode, it will try to brighten everything, and you're only trying to take a picture of the moon. If you're able to zoom, you should do that. The moon is surprisingly small in these pictures, so if you just take a regular photograph, you'll get 3 pixels of moon and lots of dark sky.
So right now you have your telescope with us, which is getting a great shot of the studio lights. But
right.
What is it actually? What would it be doing out in the field if you're actually having out there?
Right, and I brought this in so that if we had clear skies, we could actually get a feed from here. But this is just a 3-inch refractor. There are 2 basic kinds of telescope. A refractor has a big lens for gathering light, and a reflector has a big mirror. And then I've attached to the telescope just a regular DSLR. And there's a special bit that mates them together. But this allows the camera to look through the telescope as if the telescope were a big telephoto lens. And what we were planning to do, if we had clear skies, was use the live view mode on the camera. And the camera has HDMI out. And so if you had a crowd and you didn't want to line them all up and look through it individually, you could put a TV right next to the telescope, and everybody could see it simultaneously, just like we're looking at it here.
Yeah, and stuff is really starting to move a little bit more here now. Even since we started talking, it seems like there's a little bit more coverage as well, too.
Yeah, and in fact, as time goes on, from minute to minute, you should be able to see some changes in the shadow. It's going to move very quickly, particularly when we get close to 11:29. The last little bit of bright moon will be there, and as you're watching it, you can see it being covered up, which is pretty cool.
When can we expect some of the kind of reddish color to start creeping in here as well?
Almost before totality starts. What you really need to do is kind of get rid of all that very bright moon, because that's sort of dazzling your eye. This is thousands of times dimmer, but once you get into totality, your eye will adjust. Your eye has this sort of automatic exposure control, and you'll be able to see that red color.
Amazing. And when is the next one as well? Next lunar eclipse year from?
November. So anybody who's missing out, 6 months from now we'll have another one to look forward to.
Plenty of time for this one tonight still too. Like we said, 85 minutes for you to be able to view this one. So a really good window for you to get, a nice coffee. It's a little bit late here. Maybe bundle up a little bit if it's cold where you are. But in the meantime, I understand that Joy has some members of the Artemis program with her to talk a bit more about our next mission to the moon.
Hi, yes. So Earth's moon is the only place beyond Earth that humans have set foot on. And with NASA's Artemis program, we're planning to take the first woman and first person of color back to the lunar surface. So to tell us more about that, I'm joined by two NASA experts, Dr. Ryan Watkins, who is a program scientist at NASA headquarters, and Dr. Vishnu Vishwanathan, who is a research scientist at NASA Goddard. Thank you both so much for joining us today.
Thanks for having us.
Yeah, thanks.
So can you tell us a little bit about your roles and what you do at NASA?
Yeah, I'll just start off by saying it's a very exciting time to be a lunar scientist at NASA. So at headquarters, in my office, we manage the Lunar Discovery and Exploration Program. And so under this program falls the various programs that are sending scientific and technology development instruments to the moon via commercial partners, as well as on various international missions. We also do all the integration of Artemis science within NASA's directorates. So for my role specifically, one of the things I do is just make sure that our scientific instruments can meet their science objectives and have everything they need to do that. It's one of many things we do, but yeah, so getting science instruments to the moon and Artemis is a large part of what we do.
Hey, I'm a research scientist here at NASA Goddard, and I primarily use like the data sets that are obtained from scientific instruments that we have sent to space, primarily to understand the interior structure of planetary bodies, especially the moon and other planetary bodies as well, to put together a puzzle regarding regarding the evolution and formation of the solar system in general. I ask several questions like how is the moon, like was the moon always how it is as we see it in the sky today, or was it oriented in a different manner compared to several billion years ago, or does it have a solid inner core within it like we know for the Earth? And so I'm facilitated by several data sets that we've collected, such as the lunar laser ranging data, where we fire lasers to these mirrors that were left over on the the lunar surface, the lunar near side, by our astronauts and some of the rovers, and as well as the gravity field of the moon that was mapped in high resolution by the NASA Grail mission, as well as lunar topography data, for example, that's obtained from the laser altimeter on the LRO spacecraft, which is now in orbit for 13 years now. So yeah, this is just a great time, as she said, to be a lunar scientist, and I'm really excited to be here.
So can we talk a bit about what NASA's plans are for going back to the moon? So we're taking science instruments, a rover, and then humans?
Yeah, so we're actually doing a lot to get ready to go back to the moon right now. Like you said, one of the first things we're doing, besides LRO, is sending scientific instruments as well as technology demonstrations to the moon via the Commercial Lunar Payload Services Program, or CLPS for short. And so this is NASA's way of rapidly acquiring commercial delivery services to the lunar surface. So we have about 7 of these on deck right now, with over 40 instruments that it will be flying to the moon. And as part of this is the rover you mentioned, Viper. So Viper will be roving around looking for volatiles, specifically things such as water ice, in permanently shadowed regions on the moon. So these are areas that either neither or never get sunlight or rarely get any sunlight. So good places for water ice to be contained. So we will be prospecting for these areas. How much is there? What type of deposits do we see? And then how could we possibly use that for future human missions to the moon? Yes, and then culminating with Artemis, sending our first woman and first person of color back to the surface of the moon.
And this is a question for you, Vishnu. So you study the moon from Earth. Is studying the moon from Earth during the lunar eclipse particularly exciting for your type of research?
Oh yes, absolutely. So for example, right now, like during the full moon phase, right, the surface of the moon is really hot. It gets heated up. something like 250 degrees Fahrenheit, or comparatively like or 120 degrees Celsius. So these mirrors that I was talking about on the moon, these are not optimal temperatures for the moon to operate in. And so the performance of these, the optical performance of these retroreflectors, as they're called, they're diminished with time, right? So we want this kind of a window. This eclipse offers us this time window wherein the moon passes through the shadow of the Earth, so which gives these optical instruments to kind of cool down. And this enables us to make measurements, right? And so what science we can do from that is that, when this particular configuration that we are in right now, which is, the sun, Earth, and the moon, this enables us to make very high precision tests of, the universality of free fall. During the Apollo 15, I believe, the commander, David Scott, he dropped a feather and a hammer at the same time to demonstrate that, to show that, all objects fall in the external gravitational field at the same time. And similarly, what we're doing here with this laser ranging measurements is that we're trying to make use of the moon and the Earth as test bodies in this gravitational field, and so as to measure the falling of this Earth and Moon system into the gravitational field of the Sun. So by measuring and comparing what we predict with theory versus what we observe with these laser ranging observations, we are able to put a number to those limits on how accurately was the theory of universality of free fall, based on which Einstein formulated his theory of general relativity. So this is really a fascinating time, and I just spoke with one of the observers in Grasse Station in France, and if the weather is clear there, they might be collecting some amazing data for us to analyze.
Yeah, and I think Vishnu will, if you don't already know, will be very excited to know that we're sending more of these retroreflectors via the eclipse. So you're going to have lots more science coming up.
I'm truly excited about that opportunity. Great.
That's fantastic. So the last time we sent a crewed mission to the moon was about 50 years ago. So why is it important that we send humans back to the moon?
Yeah, there's a lot of really important reasons to send humans back. So the last time we were there was with Apollo, and most of the all of the Apollo missions were kind of in the equatorial region of the moon. So with Artemis, we'll be going down to the south polar region. And much like on Earth, if you travel to another country, often, the rocks there are completely different. There's just a whole new area. So also on the moon, you go down to the South Pole, there's going to be rocks of different compositions. It's going to be possibly colder in some areas. There's just a lot of different types of science questions that we will answer there. Also, we'll just be developing the technologies and demonstrating the things we need to live for longer periods of time on another planetary body, and really helping prepare ourselves to go to Mars.
So talking about long-term space travel, we had some really exciting news the other day. Scientists had successfully grown plants from regolith, which is lunar soil. What does that mean for future astronauts? Yeah.
So for those who didn't hear, we grew our first plants in lunar regolith, and this is really exciting. Scientists hadn't done this before. Lunar regolith doesn't have nutrients and water like we have here on Earth to readily grow plants. So there's still some work we have to do to understand why the plants grew differently than they did in typical Earth-like conditions. But yeah, it's really exciting. It could open up a lot of possibilities for us to potentially grow our own plants when we get back to the moon.
So we're nearing totality. Have either of you seen a lunar eclipse before?
Not that I can remember, no.
I have not either.
So it's really, we're all really excited in the studio today. So let's dig into some questions we're getting online on social media. So let's see what questions we have. We have a question from Midsummer on Twitter, and they ask, is there a delay in real time for data from the moon, like how there is an 8-minute delay from the sun?
Yes, and so this is precisely the time that we measure with the laser data, right? So it takes 2.5-ish seconds for a light beam to go from Earth, bounce back these mirrors, and come back to those telescopes. So which means that one way would be like half of that value, 1.25 seconds. That's pretty fast compared to the 8-minute.
Yeah, much faster.
And so we have a next question from Trevor on Twitter, and they ask, why does the moon turn red during an eclipse?
Yeah, so the moon, we call this a blood moon when it turns red during an eclipse, and this is because as the Earth is blocking the sun's light, the sun's sunlight is still passing through Earth's atmosphere. And when this happens, your kind of bluer wavelengths of light get scattered by Earth's atmosphere, but the red wavelengths of light still pass through, and that's the wavelength of light you're seeing reflected off the surface of the moon. It's much like reflecting back Earth's sunrises and sunsets in a sense.
Okay, so our next question is from Musical Wolves on YouTube, and they ask, what does a total lunar eclipse look like from the International Space Station?
Well, I think they will definitely enjoy a more clearer view because, there's no atmosphere up there, right, from the International Space Station. So I think it's going to look like how we see it on Earth, but just beautiful, much more prettier because, it's without all the atmosphere in between or the clouds like we have today here.
And Sydney asks, why are we going back to the moon?
That's a great question. Some of the reasons I mentioned before, the different variety of science questions that we can answer. The moon isn't really a been there, done that place. The South Polar region is a whole new area we haven't explored yet. There are resources there that weren't really available to us for the Apollo missions, again, because of the presence of water ice in the South Polar area. So we can really demonstrate how we can pull out these resources and use them for water or even for making rocket fuel that can then send us on to Mars. But yeah, so a lot of it is the science, and then also just developing these technologies and getting that experience we need in order to go on to places like Mars and beyond.
Okay, so our next question is from Denise Wright, an Earth and space science teacher from Myrtle Beach in South Carolina, and they ask, how much does the surface temperature of the moon drop on that side that we are seeing during this eclipse?
Oh, okay. I think it's about a few tens of Kelvin. At least you'll get that duration over which, I know the entire, it takes about, during a full moon phase, it goes up to like 250 degree Fahrenheit, or which is, it's like 120 Celsius. But I think, I'm not very familiar with the exact value because, this is a very long eclipse, which means like, it has sufficient time to cool down, but it takes time for the lunar regolith to respond to it. There's some thermal inertia to it. So I'd say a couple of degrees as a guess. Yeah.
I don't have a better guess. So.
Okay, so we have a question from Trevor Pollinger on Twitter. And they are asking on behalf of the Pollinger kids, has anyone ever been on the moon during a lunar eclipse?
Great question. I believe the answer is no. I don't know if one happened during Apollo or not. I actually am not entirely sure, but I imagine if they had been, they probably would have gotten a good image for us.
Oh yes, I think what they would be seeing during the lunar eclipse is like just like during the solar eclipse, when you get the totality, we see that annular ring around the moon. Similarly, you can expect, when we, during a lunar eclipse, if you were to be on the surface of the moon, looking at the Earth, it would be such a fantastic view because you'll see, not that horizon sunset that we see on Earth, but, it'd be like a ring of sunset, right, around the Earth with, the sun in the background. I think it's a spectacular view. I'd love to be there in that place to see that view. Yeah.
So there would be like a red ring around Earth. Is that what you mean?
Yes, I think so. Yeah, that's how it would look like. I believe Ernie Wright, at Goddard would, I'm sure he has made a simulation on this that shows that particular video. Check that out.
Okay, so we have a question from Yong Mei Mei. When we go back to the moon, will we set it up as a permanent settlement?
Yeah, so we are looking at establishing a lunar base on the moon, having more, permanent or semi-permanent architecture that we can then go to at a more frequent basis, send more, crews on a regular basis to habitats and have long-duration rovers and things like that. So yes, it's definitely something that NASA is working towards.
Oh, fantastic. Okay, so our next question is from Arnab on Twitter, and they ask, is a lunar mission launch possible during a lunar eclipse? I mean, not during the launch, but while it's in orbit and maneuvering to get into the lunar orbit.
I don't see a reason why not. Yeah.
Yeah, I think communication with Earth is one of the most important things, and good conditions to launch off Earth.
Yeah,
so
perfect.
the lunar eclipse shouldn't affect those things. Yeah.
So do you think there's a chance for any future lunar missions for that to happen?
Yeah, I think it'd be really exciting. I mean, yeah, there's cool visuals and probably even some cool science, that you could be done. Yeah.
Okay, so our next question is from Snazzy Zazzy on Twitter, and they ask, would the Artemis crew deal with any abnormalities if they were on the moon during a lunar eclipse? For example, extra radiation from the sun?
I think one of the difficulties that they would potentially face is, the lack of light, right? Because, you have a good amount of sunlight coming in if they were to be in the, near side. And suddenly it would be like a diminished light or much dimmer light than they are enjoying to, and I just hope they're not in one of those permanently shadowed regions when when they're doing that. So, but I think that's about it.
Yeah, and I think one thing to remember too is that generally these eclipses are not very long. The one tonight is quite a bit longer than what we typically see, but usually they're on the order of a few minutes. So even again, the lack of light could be probably the biggest issue to be concerned with.
Okay, so we're going to be taking more of your questions later on in the show, but we are nearing totality now, which is really, really exciting. So let's head back to James to see where we are, what we're seeing on the feeds, and what other people around the world are seeing.
Yeah, Joy, this is the big moment. If you're keeping score at home, we're just about 4 minutes away from the main event, Totality. And if I swipe back to the screen here, we've been tracking this view for the past couple minutes here in Ouarzazate, Morocco. They have a beautiful clear night there in the desert right now. You can see just the last little sliver of brightness here before the moon is eclipsed here for us. And we're starting to get some really interesting reddish color creeping across. And just before we went on, you were telling me something interesting about the times that we were displaying there. There's, they're not down to the exact second. We have them at like 11:29. Why is that not precise for us?
Right. You would think that we know the geometry of the shadow and we can just figure that out. But it turns out that the width of the shadow at the moon is affected by the atmosphere. And of course, the atmosphere on Earth is constantly changing. It enlarges the shadow by about 1% to 2%. But for each eclipse, it's a little bit different. So when we do the calculations, we use an average value. But we don't know precisely what that number is going to be until it actually happens. And this is actually something that citizen scientists can help with. While the shadow is moving across, you can time when that edge hits each crater, and you can do that at the end of totality as well. And this sort of pins down the size of that shadow. So, I mean, I think it's probably surprising to people that we're not certain to the millisecond when these things are going to happen. But, science is a little bit messy sometimes. And we don't even fully understand all of the effects that are changing the size of that shadow. So it's an ongoing question.
Yeah, and we've been watching them kind of adjusting the exposure a bit of the camera here to get this really dark area of the moon. And a couple of our other feeds as well have been kind of doing the same pattern as well here too. Can you tell us a little bit about this red color we're seeing start to come up here? If I'm understanding correctly, it's a projection of all the sunrises and sunsets?
It absolutely is. Yeah. Imagine how beautiful that would be to be on the moon and see it. Yeah, this is a color that's coming from all the sunrises and sunsets. It's the light filtered through the atmosphere. All the blue light is scattered away. The red light is sort of refracted into that total shadow. And so that's why it's appearing red. It's very possible that the color of this eclipse is somewhat darker than usual because of an eruption in Tonga in December and January. The number of aerosols, particles in the atmosphere, can affect the darkness. And so there's a scale that we rate the darkness. The scale goes from 0 to 4. The scale was invented by an astronomer named Danjon. And so that's another thing that people can do. They can go outside and sort of judge the darkness of this compared to other eclipses. And this one's looking a little dark.
Yeah. If you're a bit luckier than us at home and you don't have cloud cover, what kind of things can you see with the naked eye just looking up at the moon at this point?
Right. I think even with the naked eye, you can distinguish the dark parts of the moon from the brighter parts. The dark parts are called mare, and these are places where lava has infilled large depressions. So this is Tranquility, where Apollo 11 landed, and Serenity is next to it. And Imbrium is up here. These are basalts. These are like volcanic rocks, and they're very dark. You think of black beaches in Hawaii.
Yeah.
So you have a geology background, you know about this. And then the lighter parts are called highlands, and these are older. They're more heavily cratered, but they're not filled with lava. And so that's something you can notice right away just with the naked eye.
And looking at my watch right now, it is 11:29 here on the East Coast. This is the moment we've all been waiting for, totality here. There's just that last little bit of sliver of light here, so we're just going to sit back and watch this moment happen.
Yeah.
Wish we could be doing this from outside here in the Rocket Bar
I
in
know.
Goddard. Would be really nice, but you know, this is still an incredible view here from Orzazat.
Well, and one of the things that you'll notice, I mean, this bright part is just because of the difference in exposure. So
Yeah.
this part of the moon right here is closer to the center of the shadow, and that's where it's darker. So throughout totality, you're going to see this sort of gradient from one side to the other.
And so if you're at home, you know, this is the moment to run outside. Keep us in your back pocket, listening on your headphones as you run out there to take some pictures for some play-by-play. But what are some tips for this moment? You kind of went over some earlier here, but, you know, this is the moment to take a picture and share it with us wherever you're watching this.
Right. Well, and the lovely thing about a total lunar eclipse is that it lasts for a little while. So this is an opportunity just to get outside. It's an outdoor activity. You bring a lawn chair and you kind of sit back and you think about the fact that we're in the Earth's shadow every night. But this night, you are sharing that shadow with a body that's 250,000 miles away. It's the same shadow, which is kind of cool.
And I can't help but think about what that view would look like on the moon. You know, imagine if you're an astronaut up there observing that.
Yeah, I would love that. I think it was mentioned a little earlier. A question came in about whether or not Apollo or any astronaut had seen a total lunar eclipse from the moon. Almost. A plan for one of the Apollo missions was to leave the TV camera pointed at the Earth, and an eclipse was going to take place a few days later, but the camera malfunctioned, and we didn't have that opportunity. Okay. So it's another of the 1,000 reasons to go back. I think the opportunity to see it from there would just be amazing.
Yeah, and some questions are coming in from social media here as well, too. James Ito on Twitter asks, how often does this type of lunar eclipse occur?
So total lunar eclipses happen about every 6 months, but they're not always visible from where you are. The nice thing about lunar eclipses is that half the Earth can see them, but it might not be the half you happen to be in. So mostly every 6 months. Sometimes it's 5 months in between, and sometimes you can have two in a row. And occasionally that 6 month pattern is sort of broken, and what you get is sort of partial and penumbral and less interesting eclipses for a little while. And then suddenly you get a string of totals again.
Amazing. And you've had a chance to really study the moon up close with some of the missions from NASA, like the Lunar Reconnaissance Orbiter, to get some really cool visualizations. Can you tell us a bit more about some of those types of things?
Right. So this is actually what I do here. I've been working with Lunar Reconnaissance Orbiter data since it launched in 2009. And LRO is creating global maps of the moon that are way more detailed than anything we had before. I think people had the impression that since Apollo, we had the moon all figured out, and we actually knew almost nothing about it. I mean, we landed in 6 pinpoints on the surface, and that's what we got from Apollo. But LRO has been mapping the entire moon. We have millions of pictures of the surface. We have a very detailed shape of the surface. We have a record of how the temperature changes on the surface, and this also tells us something about. We got another.
Oh wow, yeah.
Yeah.
New views coming in here. This is from San Diego. Looks like a beautiful clear night there as well too. Which, you know, we got some questions here on social media. Robert Schloss is asking, does, you know, this eclipse here affect the tides? San Diego, they'd be concerned about that with some surfing. You know, how's that going to affect their surfing?
Occasionally, I mean, there are king tides, and these are things that happen during full moons and new moons. The eclipse isn't special in that respect, but it is one of those times where you might get a little bit of a tidal effect, but it won't be enormous. You don't have to worry about you know, tidal waves or anything silly like that.
Yeah.
Yeah.
Let's check out some of the other feeds here too. So this is San Diego. I'm going to check back on Rome, which they look like they have a little bit of cloud cover. We've got some buildings there. You're mentioning that if this was a little bit clearer, you'd be able to see the moon, you know, perched right there.
Yeah, because the moon is setting in Rome, it would be low in the sky, and so that was an opportunity to maybe catch the moon with all of this beautiful architecture.
Yeah, they're adjusting a little bit. Maybe it'll come into focus here in a second. While they're doing that, let's scroll down here and check out some of the other ones here. This is one from Cartersville, Georgia, the first one I opened with tonight here too. They got some beautiful red color here too. And so there's quite a gradient of the color here as well. You're mentioning that scale, the Danjon scale as well.
Right. So you can tell right away that the part of the moon that's deepest in the shadow is over on this side. This is something else that you can see with the naked eye, and the feeds don't fully capture it. If you're able to go outside and see it with your naked eye, the color is amazing. Something I've noticed with a couple of these total lunar eclipses is that the moon looks weirdly almost transparent. It looks like you can see space behind it. It's not really, but it's an effect of that sort of color gradient and the dark red and the surprising darkness of the moon. I mean, this is way darker than a normal full moon. So it just looks weird. And that's one of the things that's fun about it.
Exactly. It's different every time. And we were saying, we were noticing the settings of people's cameras kind of changing here to capture that darkness. It was really stark. I mean, there's parts that were just completely blown out just to really capture, the darkness of the moon. And so let's check back on that Rome one, see if they've kind of pulled this up again. Still looks a little bit cloudy here, but we're back to the Morocco one here, which this has been kind of the winner of the night for me. I've really loved this view that they
really
have. Really beautiful weather.
Yep. Tycho is very visible right here. This is a crater. This is a young crater in the southern hemisphere of the moon, and you can see the rays in full moon, but during a total eclipse, they look even more spectacular, I think.
So a question on Twitter, which is kind of a tricky question here. So Abby asks, what's the rarest moon event?
That's the kind of thing that you want to go back in the almanac and sort of check through it. But a kind of unusual thing happened just 6 months ago. The November eclipse was a 99% partial.
Oh, wow. Okay.
It was so close.
Yeah, just edging it there.
Just getting over to the edge. So it would have looked like this, but with a bright sort of limb there, and it never quite made it into the shadow. That's pretty unusual. Certain solar eclipses are unusual too, but to really answer that question, we'd have to go back to the records and find out what the craziest thing was.
Yeah. One more question here from Twitter as well here. Amber asks, have there ever been both solar and lunar eclipses in the same year?
Yes, absolutely. In fact, that's not uncommon at all. The every 6 months is actually when we're in eclipse seasons. And so both solar and lunar eclipses can happen. There was a partial solar eclipse just 2 weeks ago.
Okay.
And that was visible in the southern hemisphere, if I remember correctly. But that's not unusual at all. In fact, it's very common to have them paired together. So a solar eclipse either 2 weeks before or 2 weeks after a total lunar eclipse.
And we've been talking about the moon quite a bit, obviously, throughout the night here. But let's learn a bit more about why we're going to be going back to the moon, just to study so much more science.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science. It holds opportunities for us to make discoveries about our home planet, about our sun, and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Hello, so we just had a look at all the feeds and the total lunar eclipse looks absolutely stunning. What did you guys think?
It was amazing.
I think when I first saw Morocco, the feeds coming in from Morocco, I was like, okay, this is the winner for today. But you just showed me another image from Rome, and that just changed my mind. And that's like really a reddish, nice hue across the entire moon, and such beautiful images.
Yeah, so we have a lot of questions online, so let's dig in. Let's see. So we have a viewer who asks, what kind of new and better equipment do you need to have to return to the moon, and when will astronauts arrive on it?
Yeah, there's a lot of different and new equipment or improved equipment that we're looking at for the moon. One of which I think I've mentioned a few times is that we're looking at using the resources that are on the moon. We haven't done this before. So all sorts of new technologies, whether it's drills or just systems that can extract oxygen and water and things from the lunar regolith. These are all new systems. We're improving things like our precision landing. You know, how accurately can you land where you want to land, and how well can you avoid obstacles like craters and boulders and things. So those are some things related to landing. But yeah, different sampling techniques for the astronauts, all sorts of new technologies, which is really exciting because these will be useful for Mars and also for our lives on Earth. As far as when they're getting there, NASA's targeting 2025 for our first crewed mission.
And so you mentioned it will be useful for us on Earth. Could you tell us more?
Yeah, I mean, I don't have a lot of specific examples off the top of my head, but, you know, for the Apollo program, for example, we call them spin-offs. There are all these technologies that NASA developed for the lunar program that then became useful on Earth. I think tennis shoes are a good example of one. I don't know if you have any other examples you can think of off the top of your head.
I can't think of something right now, but yeah, I think so. I think the thermal blankets that were used for the entire during the Apollo space program and the space race are being heavily used on Earth for a variety of purposes, and even these retroreflectors. I'm sorry, I keep going back to those retroreflectors. That's what I do for work. So I, you know, when I explain it to some like a child, what do? I make them look at all these on the road as you travel, when you shine your headlight at them, it comes back right at you. And those are miniature versions of the same thing, but just that they're not space grade, right? They're not ready to go to space. But yeah, there's a whole lot of equipments which were developed during the space race and the Apollo era, which is being used right now on Earth to make our lives better.
Fantastic. So we have a question from Charlie Kelch from YouTube, and they ask, can you tell us the difference between a solar and lunar eclipse?
Of course. So during a lunar eclipse, what comes between the sun and the moon is the Earth. So that's what we're witnessing today. And similarly for the solar eclipse, what we have in between, the object in between, is the moon. And it's not safe to look at by eye the solar eclipse, but it's very safe to look at the moon. So I encourage you all to go out and look at the moon if you get a chance to. Yeah.
And what are the differences when you look in the sky? Because they look pretty different.
Right. In one of them, you have the sun in the background, so it could be during the daylight, right? And then suddenly it goes all dim here on Earth when this is the solar eclipse. And lunar eclipse, they usually, to have a lunar eclipse, you need a full moon, right, to get that configuration for the eclipse. And so these are typically visible at night. So that's one of the differences I can think of.
Okay, so we have a question from Jack, and he asks, how much do we know about the far side of the moon? Mapping, geography, etc. Has a satellite sustained a durable orbit around the moon in order to map the surface? And has that ever been done?
Yes, great question. So yes, Apollo, obviously, those were all near side missions, but we do know a lot about the far side as well. We have the Lunar Reconnaissance Orbiter, LRO, has been orbiting the moon for almost 13 years now, and yeah, doing a lot of the mapping that was asked about, mapping topography. We had Grail that mapped the gravity data of the moon. So we don't have, we haven't had any surface missions from the U.S. to the far side of the moon. We haven't returned those samples, but we have a lot of really great orbital instruments that tell us things about the composition and the topography. We know that there's not as many volcanic areas on the far side of the moon. We know the crust is thicker. I think the composition's a bit different, but we don't really know why. So there's a lot of good reasons to go explore the far side as well.
Okay, and so Kelsey on Twitter asks, my 8-year-old Nico is asking, when is the Artemis mission going to the moon?
Great question, Nico. Yeah, so it depends on which Artemis mission you're talking about. We'll have our uncrewed demo this year, and then our first astronauts will hopefully be on the surface in 2025.
Okay, so our next question is from Tiffany on Twitter, and they ask, what is the moon's core made of?
Oh, so, the moon's core, so it depends on how deep you're going, right? So we know from, initially from, again, lunar laser ranging data, by looking at its orientation in space, we kind of figured out by, monitoring these retroreflectors. We have about 5 of them. We've been monitoring them very closely over a long period of time, and we were able to reconstruct the orientation of the moon, predict it, and compare with observations. So when you stick in a liquid core in that model, it very well agrees with the data set. And this is one of the findings from initially from the lunar laser ranging data, but it was also later confirmed by reanalysis of seismic data that was collected from the Apollo mission. So indeed, it's made out of a liquid core, but there is an expectation that there could potentially be also a solid inner core within that liquid core, just like for the Earth. And this is currently, in research, and we still don't have a very strong evidence suggesting that the moon has a solid core, but some of the samples that were returned from the moon during the Apollo missions, they had remnant magnetism in them, and those are signs that at some point in time the moon had an active magnetic field, and so that potentially magnetized these rocks that were returned. But currently we know that there's no magnetization, there's no active magnetic field. So, it's which suggests that there's potentially maybe a very small solid inner core, which is, so it's definitely an active topic of research, and we are seeking answers to this via, several of those missions that Ryan was talking about. So yeah, we know for sure there's a liquid core, but a solid core, my bet is indeed there is, but we want evidence for it. We are scientists, so we want evidence.
That's fascinating. So we have a lot more questions to get to later on in the show, but let's go back to James and Ernie right now to see what the lunar eclipse in totality looks like around the world.
Yeah, thanks so much, Joy. We were just looking at a feed from Nebraska a second ago. It just switched off, but they had the most red-looking moon. It was incredible.
It was beautiful, wasn't it?
Yeah, we were tracking this earlier. The weather looked really nice from Nebraska, so they must have had a beautiful, clear night there.
Yeah, in fact, I was saying earlier tonight that's the clear part of the country. That's the part that's not affected by clouds, and it turned out somebody was there watching. That's great.
Amazing. Yeah, and so a couple questions have come in on Twitter as well here, too, and I think you can really speak to these very well. Karthik asks, why do lunar eclipses happen rarely and not every 28 days?
Right. That's a great question, and it's because the moon's orbit is slightly tilted. So 5 out of the 6 months, the moon is going to pass either underneath the shadow or above it. It's only when you get that tilt oriented just right so that the moon is going right along that line that connects the Earth and the Sun that you get lunar eclipses and solar eclipses as well. Those are related. So a lunar eclipse is always the full moon, a solar eclipse is always the new moon, so they're at opposite ends of the orbit. But that's what eclipse season really means. It's when that tilt is oriented in such a way that it's sort of crossing through the center line.
Got it. Amazing. And, if you're just tuning in, too, this is really going on quite a bit longer after our broadcast here as well, too. So, stick around, put on another pot of coffee if it's getting late for you wherever you are in the world, and just take your time to observe and really enjoy this view here, too. Another question from Twitter from Lucas. He asks, how do you calculate the next lunar eclipse, or any eclipse for that matter?
So that's something that we've actually gotten very good at. The calculation of the position of the moon, the Earth, and the Sun. And these are the critical elements that you need in order to understand when an eclipse is going to happen. We can predict those 100 or more years into the future. And what you need to do is just roll that clock forward while you're doing the calculation and find out where everything lines up again. And that's basically how you do it.
A little bit dark here. This is, I think, San Diego. Oh, there's the feed. This is the one that we were seeing. Let's pull this one up big here. This is an absolutely stunning view out in the plains of Nebraska. Gorgeous, gorgeous shot here of the moon. Really love this one as well. And so, unfortunately, here it stayed cloudy for us, a lot of thunderstorms, but I was actually able to visit the moon from our own Goddard Visitor Center. It was a lot of fun. We got a nice close-up view of it here. Hoping for a bit better weather, for the next lunar eclipse down the line here as well. So we'll see how that goes as well. Joy, how was your trip up to space today?
Yes, I highly recommend going to NASA's Visitor Center in Greenbelt, Maryland to go to the moon yourself as well. So we have a lot more questions from social media, so let's get chatting. We have a question from TJ on Twitter, and they ask, why do we have to wear special glasses during a solar eclipse, but not during a lunar eclipse?
Well, the solar eclipse, during a solar eclipse, you're looking at, the sun and the sky, and you don't want to look at the sun directly because of all the harmful radiation, such as like UV light, etc., that's coming in at all times. You should never look at the sun, right? So even during the solar eclipse, what happens is, you get that really drop in, sunlight, and so you have a really dark place, and suddenly when the moon moves away, you get this sudden bright, so which can damage your eyes. So that's why they recommend you to wear a filter. Whereas for the lunar eclipse, you're looking at just like looking at a moon during a full moon, or a waning, or during the other phases of the moon, is the light which is bounced off from the sun and then coming to you. So that's much less bright, and they're not as harmful as that looking at the solar eclipse.
Okay, so we have a question from Nip Per on NASA Moon Facebook, and they ask, with the moon receding from the Earth about 2 centimeters per year, how long will it be until there will be no total eclipses? Or by mega coincidence, will the sun shrink at the same ratio?
Really great question, and I don't know that I know the answer. Can we shout that one over to Ernie?
I think, we can make that calculation because we have the models that can extrapolate it based on the current data sets that we have to the future. But at some point we're not going to be able to witness like a total solar eclipse either, because we'll have the moon becoming smaller and smaller as it goes away. But it's a calculation that needs to be done before it can be answered.
It won't be in our lifetimes.
Yeah.
Okay, so we have another question. Mauricio Leco Electronic on YouTube asks, is there gravity on the moon?
Yes, the gravity on the moon is 1/6 that of Earth. So that's why if you see videos of the Apollo astronauts, they kind of look like they're hopping around, kind of almost in slow motion, like, because there is gravity. It's just not quite as strong as ours.
Okay, so we have Loudon on Twitter, and they ask, why are lunar eclipses only visible from certain locations?
Oh, I think so. To be in that shadowed region, right? So the moon's orbit is slightly inclined. So what happens is there are only specific points in the orbit where you can have that shadow. So as long as the moon is visible in the sky, when the moon is passing through that shadow of the Earth, you'll be able to see that, and that's probably why.
Okay, so that is all we have time for today. Thank you both so much for answering everyone's questions online.
Yeah, thanks for having us.
Yeah, pleasure.
And thank you to everyone joining us at home for this remarkable experience. Remember, Totality ends at 12:54 a.m. Eastern Time. So if it's not cloudy where you are, I recommend you head outside and check out the red moon. If you want to learn more about the moon, head to moon.nasa.gov. And if you want to learn about NASA's latest research around the moon, follow us on NASA Moon on Facebook and Twitter. And we will be continuing to stream the lunar eclipse on moon.nasa.gov. So head over there so you can check out the lunar eclipse at different locations across the world. And mark your calendars for the next lunar eclipse, which will be on November 8th. Until then, see you next time.